Algebra 2 4.4c. This is part 2 of Solve a System in 3 Variables, x, y, z. If you haven't seen the previous videos for Chapter 4, you're going to get confused. So my advice is to see 4.1, 4.2 a, b, c, and d, 4.4, and of course 4.4b. All right? So I don't want you to get confused. We talked about 2 variables and 2 equations. Now we're doing 3 variables and 3 equations. And you really need to see part 1, okay? And that link is in this video's description. So as I said in the previous video, we can't solve a system of equations in 3 variables by graphing because they have to be graphed on a 3-dimensional plane. And it would look like this. This is the plane that it would be graphed on. So we've got 3 sheets of paper here, this one, and then the one bisecting it. And we can't make one of these for every single problem in our algebra book. So we use elimination and substitution. We use linear combinations followed by substitution to solve these. And you need a lot of room to do your math, okay? So this might take a full sheet of school paper or half sheet of school paper to solve this. So give yourself some room. Now, with elimination and substitution, we can solve this system of 3 equations. And I've got them color-coded like I did in the last video, but I've got this laid out a little bit differently, okay? So our green circle equation is going to be the first one, our blue square equation is going to be the second one, and our red triangle one is going to be our third equation. Now, the first thing that we need to do is take this third equation and multiply it by a 2, so that each coefficient here is a multiple of this 2x. Then we'll have 2, 4, 6, won't we, for the x coefficients. So we take this guy and we multiply him by 2, and we don't forget the 4. Every term needs to be multiplied by that 2. And then we get this new version of our red equation, which is 6x plus 6y minus 2z equals 8. All right? So now our system of 3 equations looks like this, because now we multiplied this one by 2. This is our new system of equations. So now we've got our circle green equation, our square blue equation, but we got a new triangle red equation, okay? Now what we're going to do is we're going to take the first equation, we're going to multiply it by a -2 to every single term, even the 24, and then we're going to add it to this blue square equation to eliminate that blue x, okay? So we multiply each term by this -2, and we get -4x plus 8y minus 14z equals a -48, okay? Now we move our blue square equation over, 4x plus 2y minus 3z equals 4, and we add them together. And that's going to create a 0 pair right here, isn't it? So what we ended up doing is by multiplying this first equation by a -2, we created a -4x and a +4x right here so that we could eliminate that x. Now our new blue equation is 10y minus 17z equals a -44. All right? So now our system of equations looks like this. Now we have a new blue equation and a new red equation. See? And now our system of 3 equations looks like this. We still haven't really changed that first one, okay? Now, we're going to multiply the first equation by a -3 to each term, even the 24 at the end gets multiplied by the -3. And we're going to add it to this new to this new red equation here so that we can eliminate this red x. By multiplying this 2x by a -3, we're going to make a -6x and a +6x, so we can eliminate this, okay? So we multiply every single term, even on the other side of the equal sign, by that -3, and we get -6x plus 12y minus 21z equals -72. We add it to our new red equation. We create a 0 pair here, and now we have a newer red equation. So this was the new red equation. This is the newer red equation, okay? When we add these together, we get 18y minus 23z equals -66. Now our systems of equations looks like this. So now the green one is still the same. We have our blue one, that new blue square equation, but now the new red triangular equation is now a newer red triangular equation, okay? Now what we're going to do is we're going to multiply the blue one by a 9 and the red one by a -5. And what that's going to do is that's going to create a zero pair for the y values. See, we had to find somewhere that we could eliminate the y. Where can 10 and 18 meet? They can meet at 90. So we had to multiply the blue one by 9 and the red one by -5 to create a negative and positive 90y so we can eliminate it. And we multiply every single term of the blue one by that 9, including the -44. And we multiply every term of this red equation by this -5. All right? And now we've got these two equations, and when we add them together, we eliminate the y, and we get -38z equals -76, and divide each side of the equation by the coefficient -38, and we end up with z equals 2. Now, we don't have to use the red equation anymore because we know z equals 2. What we do is we take that 2 and we stick it into the new blue equation here, this 10y minus 17z equals -44. We put 2 for the z because that's what z equals, okay? We substitute it in. Now, we can solve for y. And we end up with 10y minus 34 equals a -44. We can add 34 to each side to create a zero pair here. Isolate the y as a 10y equals -10. Divide each side by the coefficient 10, and y is a -1. Now we know that z is a 2 and y is a -1. We can plug that into the first equation, the green one, the one that we never really touched. And we end up with x equals 3. When we plug them in, we get 2x plus 4 plus 14 equals 24. And when we combine the like terms, 4 and 14, we get 2x plus 18 equals 24. We subtract 18 from each side of the equation and get 2x equals 6. We divide each side by the coefficient 2, and we get that x is 3. Oh, a lot of work, huh? It's not that it's hard, it's just that it's long and drawn out. Now we can substitute our ordered triple, 3, -1, and 2, into each of the original equations up here to see if it solves the entire system. If it does, then we know we've got a solution for the system of 3 equations. All right? So I tried going sideways in this one. If you saw the last video, I went downward, and I was thinking maybe if I presented it this way, it might make more sense to other people, because everyone learns in a different way. So we just came across, all right? So if you have to watch this again, that's no big deal, you know? So what? 10 minutes of your time to watch a video again, all right? To make you understand. So we can use elimination and substitution to solve systems of 4, 5, 6, 7, 8, 9 equations in a system. It's a lot of elimination and substitution, though. And by creating common multiples, we can use elimination. So what we did was we created common multiples, didn't we? The first common multiple we created was that 6. And then we multiplied the equations by a 9 and then by a -5 so that they were multiples, right, of the new y, so that we could create that zero pair. The goal is to create zero pairs to isolate each variable. That's all. Whatever you have to do, whatever you have to multiply the equations by to create zero pairs to slowly isolate each variable, one, then another, and substituting those values in until you get them all, okay? Our next video is 4.4D, and you really should watch it. It's triangularization algorithm to solve systems of linear equations. It kind of explains what we're doing, but in a triangle. And I'm going to add this video to the Algebra 2 playlist so you can use it to study for tests or to catch up if you've missed anything. And, of course, that System of Equations playlist from Algebra 1, that Chapter 8 playlist is going to be in here in the description, okay? So it's very important that you watch all the videos for Chapter 4 to understand what we're talking about. If you don't understand, then you didn't watch the videos. You're walking into the end of a movie wondering why you don't understand the story, okay? So, I'll see you next video. Let's talk about triangularization algorithm, and I hope you're having a great day. Bye.